We'll proceed in vector summation and integral calculus. Okay, so vector summation and integral calculus, the discussion in arena in which we are pursuing this discussion. Vector summation and integral calculus. Can I divide problem into n different parts and solve it part by part? Sum it and then n make it to infinity. Okay, while solving a problem into n different parts, part by part, each part should be solved through vector. That is the concept that we are pursuing. We if I have a length, if I have a line connecting 2 points, this line can be described through length vector. This is what we have taught, length vector. Anything in calculus, anything. Calculus is a game of algebra. Calculus is not game of vector. Vector can be algebraic vector where components of vector are algebra, and on each components calculus would operate separately. Okay, it's not that all together in a vector we are applying calculus. Calculus eats. Okay, if rat eats cheese and butter, then calculus eats algebra. Means that is its food. So if I have a vector that is 2i plus 3j, then what is calculus? Nothing. If you derive, it will become 0. If I have a vector called xi plus yj, if I just say I have to find derivative of it, it will become dxi plus dyj. Okay, many people they find it very different. What is dxi and dyj? If I have a vector xi plus yj, what is derivative of the vector? Derivative of the vector. Derivative with what? Okay, I understand you are talking about derivative of the vector. Derivative with respect to what? Because derivative means division. Division with respect to what? No, just that. These are the false things generally you will find in the book. Okay, let d of the p, small d and p. P is the position vector. What is the position vector? Xi plus yj. Understand? It connects a point 0, comma 0 and point x, comma y. Xi plus yj. What is derivative of this vector? What do you mean? D of p. Derivative of what do you mean? D of p. Okay, what is d of p? Derivative of this vector. I don't know what is d of p. I just said d of p, derivative of this vector. Okay, derivative of with respect to what? Derivative of this vector with respect to what? Okay, but I have something derivative of the vector. Then the derivative of the vector means I can relate it to nearly to something like that as this point is origin and this point is x comma y. This point is origin and this point is x2 comma y2. This point is x1 comma y1. This point is x2 comma y2. This is p1. This is p2. What is the vector that passes through this p1 and p2? Then it is x2 minus x1 I plus y2 minus y1j. X2 minus x1 I plus y2 minus y1j. If a vector is passing through these 2 points, that is the vector representation. That can be written as again x2i plus y2j minus x1i plus y1j. It is same as p2 minus p1. If I say what is the vector representation of a vector that is going through point p1 and p2, that is nothing but p2 minus p1, p2 minus p1. p2 minus p1 is a vector that connects this point and this point. I can say it as a delta p. I can say it as a delta p. Delta p. If the gap between these two is very small, I mean x2 minus x1 that falls on x-axis, considering y is dependent upon x, y equal to function over x. X2, this is x1, this is x2, this is x-axis, x2 minus x1. Consider it is infinitesimally small. In that fashion, the delta p will be very small. If it is very small, then I can write delta P at dP. This is the one clarification someone can give. But again, delta x comes into the picture. So if I say d of P means d of P with respect to what? Be d of P with respect to delta x. Or someone can say, consider d of P. Then you can write d of P by dx into dx. Now what is d of P? dP by dx, whatever you get, into dx integral. First differentiate it and then calculate what is the meaning of this. You differentiate it and you then do the integral. You will get dP. And what is meaning of this? Same thing, right? P only. P is same. I'm sorry. If I say dP, then dP is same as dP by d. I'm trying to calculate dP. What is dP? dP I can say loosely delta P. dP is same as dP by dx into dx. dP by dx, what you get is a vector. Okay, then integrate between, you will get same thing. No, no, no. There is some tweak there sometimes. What is tweak here? dP by dx, whatever vector is coming, if you calculate the magnitude of it, magnitude. If P is xi plus yj, dP by dx will be I plus dy by dxj. If you calculate magnitude of it, square root of 1 plus dy by dx whole square. And then if you say integration with the dx, x from one location to another location, x1 to x2, then you will get this length. What this length is, that is delta p. What is dp? Delta p, understandable. If you mean that fashion, understandable. What is delta p? What is delta p? Delta p is x2 minus x1 whole square plus y2 minus y1 whole square, a square root. Okay, but why you are going through that? Why am idiot? Delta p means delta p. Yeah, delta p. That is x2 minus x1 whole square plus y2 minus y1 whole square square 2. But that is a straight line. Yeah, that is a straight line. What about if it is connected through a curved line then? If it is a connected through curved line, then it is not connected through a straight line. It is connected through a curved line. This point is x1, y1, this point is x2, y2. But the connection is not a straight line, curved line. If it is a curved line, if I say delta p, that is p2 minus p1, then that will talk about a straight line. Okay. If I say delta p by delta x, where delta x tends to 0, then it will talk about dp by dx. Means this is a delta p is a vector that is a resultant of delta x change on x axis, that is x x2 minus x1. It will be a negative here. x2 minus x1. That is because of x2 and x1, because of this delta x on x axis, the resultant is delta p. Delta p by delta x if x2 minus x1 tends to 0. If it is tends to 0, then delta p by delta x will become dp by dx. Means how much this position vector is changing. If this is the position vector in one time, when x is here, if x is changing little bit, one unit can be infinitesimally small, 1 picometer. Then where p is going? dp by dx per unit change in x brings how much change in p. If this is p1, then another p is here. If this is p, then another p is here. These results are coming because of one unit change. One unit change means infinitesimally small. If I keep taking all the points with one unit change, I'll go along the curve. Makes sense? This is where differentiation matters. Differentiation is nothing but y by x at a particular moment. I have a line like this. It connects point x1 y1 and x2 y2. It connects like this. Okay, I say what is what is delta p? If this point is p1 and this is p2, then if there is a straight line, if there is a straight line that connects, if there is a straight line that connects the 2 points, if this is a straight line, then p2 minus p1 is the vector delta p. Delta p is nothing but this is x1, this is x2. On x-axis, it is delta x. Because of the delta x movement, x2 minus x1, my position vector changed from p1 to p2. It is delta p by delta x or delta p. What is delta p? Delta p is x2 minus x1 I plus y2 minus y1 j. pi delta x x2 minus x1. Because of that change in delta x x2 minus x1, I saw p1 changing to p2. I saw that. Okay, if I say delta p by delta x, but delta x tends to 0, it is exactly like first principle in differentiation, dp by dx. Means per unit change in x brings how much change in position vector. If this is p1, this is x, I make one unit change, not delta x change. Delta x is very big still. One unit change maybe tends to 0. One unit change. In that fashion, p1 became p3. What is delta P now? Now, if P3 is P1, if I move one unit again, then P3 becomes another P4. If P4 is P, then it will move again if I make one interchange P5. If I keep doing like this, it will exactly move along the curve line. If this is the curve line, if they are connected through a curve line, it will exactly move through the curve line, not through the straight line. Not through the straight line, to start moving through the curve line. This is miniature science. Means if I say delta P is a line that is connecting P1 and P2. But if I say dP by dx, then dP by dx, then it talks about delta P that happened because of one unit change along x-axis. Okay, then what is delta P? Earlier you said P2 minus P1. Okay, that delta P is seen because delta X is changed along x-axis, x2 minus x1. Though I have not divided it, but still that delta P has resulted because change in x-axis is x2 minus x1. How much delta P will result if change in x-axis is one unit, that may be 1 picometer, 1 nanometer. Then it will be delta P by delta X. That is delta P by delta X. Okay, what dP by dx? What is dP? Not dx or something. What is dP? No one can say what is dP. It has to be in respect to someone. So someone say, okay, why you are talking about dP? Because I am trying to calculate the length of this curve line. Length of this curve line. dP, I am thinking if this is origin and this is P, if this is position vector and dP delta P, if position vector is changing along the curve, then this older point was P1 and new point is P2. Okay, then how much it has changed? If this point is x1 y1, this point is x2 y2, then what is dP? dP is nothing but delta P, x2 minus x1 I plus y2 minus y1 j. This is what I want. Then x2 minus x1, you can say delta x. Yeah, delta x I. Then y2 minus y1, you can say delta y. Yeah, dy. So it is dxi plus dyj. But perfect would be, but why you want this? Yeah, because if I know delta dp, then if I calculate the magnitude of dp, I'll get the circumference length. Okay, what do you mean? What I mean is, if this is radius, and this is Cartesian coordinate system, x-axis and y-axis. This is radius that is moving in angle theta. This is radius and it is moving with angle theta. It is making this arc while it is moving. This arc is guided by angle theta. This length is r into theta. This is r. This rotates 2 pi degree. This is another coordinate system for polar coordinate system. If I divide this angular movement into n part, or if I divide this circumference into n part, then this will be first part, second part, third part, and this is the ith part. If this is ith part, then this is position vector P and this is position vector P1, this is P2, point P1 and point P2. If I get dP means the distance between these two. dP means the vector that is going from this point to this point. That is dP. If I calculate the magnitude of the dP, I'll get the length of this ith section. This is the ith section of the chopping of the angle. This is the ith section. This is the curve. This is P1, this is P2. If I know dP, derivative of P means this. This is dP, derivative of P. If I know derivative of P, then if I calculate the magnitude of derivative of P for the ith section, I get the curve length. And then I'll add for all, I'll get circumference. Why don't you do delta P? No, no, delta P problem, it is a straight line. Delta P, P1 and P2, delta P, it is a straight line. But dP will give the curve line length. That is the difference. Difference between delta P and dP. Delta P will give this point and this point a straight line connectivity. dP will give a curve line connectivity. How it is? Because delta P, if I take, then how much is this change in vector with respect to, if this is x1 and this x2, with respect to x1 minus x2. If I talk about dP, derivative of P, that will also give the distance between these two, probably not these two, this point and any other point. When the here gap is 1, that is 1 means I have chopped into n part x I have chopped this into n part where n tends to infinity. In that sense, I am talking about 1. Or still 1. 1 is negligible. Okay, 1 picometer or 1 to the power minus 100, that much distance. In that fashion, the delta P will be along the line, along the curve. If this is big, then it will be a straight line. But if this is small, then it will go along the curve line. When delta P will go along the curve line. If this is P, then because of one unit along x-axis, another P, if I talk about, then it will be very near. It will go like this. Then if this is P, then it will go very near here. Slowly it will start moving along the line only, and then it will reach here. Make sense? Means if I say dP with respect to one unit, that is dP by dx. Yeah, but I want dP because dP is the vector between these 2 points along the circle. I am trying to calculate the circumference length. Circumference length means along the line, along the circumference. If I want distance between any 2 points, I'll say dP, delta of position vector. We understood delta of position vector. But delta will give a coarse length, that will be a straight line. Minute length, if I want, I'll say dP. If I calculate magnitude of dP, I'll get the circumference length. Okay, okay, that is true. Okay, dP, if I say dP with respect to what? With respect to x, then if I say dP by dx, then it will be dP by dx into dx, because at the end I want a dP. Because dP will give the circumference length, not dP by dx. dP is delta P, one point to another point on circumference is distance. But to go with, there is nothing called dP in calculus. dP is a hypothetical word. When I'm trying to calculate the circumference of this, if I cut this angle into n different parts, this is the ith section. If I have this as point P1 and this is a point P2, if I connect this, then this will be a straight line. Delta P is a straight line. Delta P is generated because of x1 and x2. Okay, but I want along the curve length, then I'll go with the dP instead of delta P. Okay, dP is again this point and another point on the curve. Then this point, another point on the curve. This point, another point on the curve. That is dP. But there is nothing called dP. dP, delta P is understandable. True end of this is ith section. But what is dP? dP by dx is alright for you, right? Yeah. Then consider dP by dx into dx. Now it will be dP. Yeah. dP by dx. I want magnitude of dP. Then dP by dx magnitude. Because a little bit I extended. So if I say dP by dx, whatever it comes, its magnitude, whatever it comes, then if I integrate with dx, I'll get by dP. Idea is to get dP. Magnitude of dP. If I get magnitude of a dP, then I'll get the slight length. dP by dx, then again magnitude, and then integration with dx, then I'll get the actual dP I wanted. dP by dx into dx is dP only, delta P, magnitude. So actually what I want is, what is the circumference of this circle? Circumference of the circle is, if I divide this circle, if I divide this angle from 0 to 2 pi into n different parts, where this is part number 1, sorry, this is part number 1, this is part number 2, this is part number 3, this is part number ith part. This is ith part. If this is the ith part, Then if this is the point number P1 and point number P2, then this length is delta Pi, delta P of the ith section. Summation I equal to 1 to n delta Pi. For all delta P, if I add, I'll get the circumference. Summation I equal to 1 to n and then magnitude of delta P. If this is point P1, this is point P2. Delta P is a vector which will connect P1 and P2. Its magnitude, what we want. Delta P, its magnitude. Delta P is a straight line, but I don't want a straight line. I want the length of this section through the curve only. If you want through curve, then rather delta P denotes x1 minus x2 or x2 minus this big section. This is delta theta I. This is theta. This big section delta theta I or delta xi denotes. But you want for one section only, one unit, that is delta P. Yeah, I want delta P dP. I want dP, not delta P. Delta P is very big and it is straight line. If I say dP, that will also be a straight line only, but distance will be very minute. If I proceed slowly, then from here to here, I'll go slowly along the curve only. What do you want? For ith section, I want dP. Through dP, I want this length. There is nothing called dP. Okay, then dP by dx. You want magnitude of dP? Yeah, I want magnitude of dP. Then dP by dx into dx. dP by dx you calculate and then get its magnitude. Whatever it comes, then you have to multiply with the dx. Multiply with the dx. dx is nothing but delta x, but delta x tends to 0. Okay, what is delta x? Delta x is between this point and one unit point from here. That is 1 whatsoever. Okay, that tends to 0. Okay, but what is dP by dx? dP by dx is that if dP is the length of, if dP is the vector that connects two points, then dP by dx is the change in this point with respect to x. That is dP by dx. Okay, if I have a rate of change, then if I integrate with the change dx, I'll get the length. I mean, these are the philosophy. There are many ways. There are many ways we come to this formula. dP by dx, its magnitude. Actually, the length of the vector of the ith section. If I talk about the ith section length, then it is delta d. It is delta p. P1 minus P2 is the ith section. If I calculate the magnitude, it is the ith section length. Okay, but I don't want a straight line length. I want the curve line length. If you want curve line length, then this is x2 minus x1. That is very big. Okay, you have to think about something that is very small. Think about something that is very small. There is other fundamental also. The angle, if I have broken this angle into n different parts, let's make n tends to infinity. If n tends to infinity, then these 2 points, P1 and P2, they will come very close, very close, tends to 0. Delta theta I tends to 0. In that fashion, delta P will become dP. Delta P will become dP. It is very small, okay? But still, dP means one unit, per unit change, how much I see. Okay, to get that, now we will divide delta P by delta X. Delta P by delta X into delta X. But my main aim is to get delta P because I want the curve length. I don't want to divide by something because if I subtract P1 with P2, I get what I want. That is, and P1 minus P2 is a vector. If I calculate the magnitude, I get the length. Then all length you add it. Summation I equal to 1 to n. N tends to infinity. Delta P of the ith section, its magnitude. This is the answer I want. Okay, if this is the answer you want, then delta P I, if delta P tends to 0, means if this n tends to infinity, means delta P tends to 0. If that is the case, then it will be converted into dP. What is dP? There is nothing called dP. But it should be calculus, it tends to 0. But still there is nothing called dP. D of position vector. Okay, but I want magnitude of dP. Because delta Pi, now it tends to 0. Delta Pi, when n tends to infinity, then this delta P tends to 0. In that sense, it will become dP as per the calculus. If anything tends to 0, it will become dP. Magnitude of dP of the ith section and summation I equal to 1 to n, n tends to infinity. But there is nothing called dP. Okay, it is possible if you divide by dx, dp by dx into dx, then it will be same dp you want, right? Yeah. Then it will become dp by dx magnitude into dx. Same thing. What is dp by dx? Then someone has to calculate. What is p? P is xi plus yj. Then dp by dx is I plus dy by dxj magnitude into dx. That will become 1 plus dy by dx whole square of square root dx. Whatever it comes, if someone dx, okay, this is the this is the length of the ith section, 1 plus dy by dx whole square root into dx, or someone can write dx as delta xi. Delta xi is delta x, that is from this point to this point, this is delta x. 1 plus dp, I'm sorry, 1 dp by dx, okay, 1 plus dy by dx whole square root into delta xi is the length of this section, smooth section, not the straight line, smooth section. Okay, if n not tends to infinity, then it will not be a smooth section. Okay, but if n tends to infinity, then delta p will change into dp, and then dp by dx into dx, then 1 plus dy by dx whole square root into the delta xi. Okay, now delta xi is the width of the ith section. Now if I convert into integral calculus, then it's straightforward. I can convert now. Square root of 1 plus dy by dx whole square dx. X is from lower limit to higher limit. Then it will give one side. Let's proceed here. How much it will be? How much it will be? Okay. What is the relationship between now? Now I have a circle. Hope. Okay. 1 plus dy by dx whole square root and dx. How much it will be? Dy by dx, if I calculate dy by dx, then it will come as minus x by a square root of a square minus x square, y equal to square root of a square minus x square. Then it will come as, I believe, a by a square root of a square minus x square. It will come, a is the radius, a by a square root of a square minus x square dx, where radius is constant. Radius is not changing. The length of radius is constant. In that fashion, it will come as a by a square root of a square minus x square dx. I believe it is all right, the way we are calculating. Okay, now let's go with another concept here. Okay, when I said what is the length of the ith section? The length of the ith section is delta p, that is dp. dp, if delta p tends, if this angle tends to 0, dp summation I equal to 1 to n tends to infinity, dp. When it is dp, then I said dp is same as dp by dx into dx, then it will be same as dp by dx into dx. Yeah. What is p? P is the position vector. What you said position vector? Xi plus y. But I can take p as any position. Yeah, you can take any position vector. Any position. Yeah, you can take any position vector. Okay, if this is x-axis and this is y-axis. Okay, if I have divided this angle into n different parts, then this is the ith part. This is the ith part. If this is point P1 and this is point P2, then this is delta P. If this angle tends to 0, then delta P will become dP. D of P. P is position vector. This position vector can be then in polar coordinate system. Yes, it can be in polar coordinate system. Okay, in polar coordinate system, this point is r comma theta as per the formula. But we say it is r comma theta r. If I draw a polar coordinate system inside Cartesian coordinate system, hybrid mode, then any point is r comma theta r. R is this and theta r is the r, not r comma theta. If I take in that fashion, then it becomes dp, d of r, r unit vector plus theta, r theta, theta unit vector by dx. P, I can take anything. Yeah, you can take anything. No one is stopping you. After all, it's a position vector, right? Position vector, if as long as someone is talking about Cartesian coordinate system, inside that you can superimpose a spherical coordinate system, polar coordinate system, cylindrical coordinate system, anything you can push. dp by dx, p can be anything. Let's try dr by dr r unit vector plus theta r unit, r theta theta unit vector by dx into dx, its magnitude, first magnitude. What is dr r unit vector plus r theta theta unit vector by dx? How much it is? Okay, I believe it's a normal question. How much it will be? Okay, let's break it. Then it will be dr by dx, dr by dx, r unit vector, plus dr theta by dx, theta unit vector, its magnitude into dx or delta xi for the ith section, summation I equal to 1 to n tends to infinity, and then dr by dx r unit vector plus dr theta by dx theta unit vector, its magnitude into delta xi. Delta xi belongs to this delta xi of the ith section x. Okay, let's proceed. What was earlier when we took p as xi plus yj? If we took xi plus yj, it resulted in a by a square root of a square minus x square dx. How it will come now? Now, if I take magnitude, it becomes dr by dx whole square plus dr theta by dr theta by dx whole square root into delta xi. Summation I equal to 1 to n tends to infinity. I will not go beyond it. Now, it can be converted directly into the integral calculus. Considering the first part, that is dr by d theta whole square plus dr theta by dx, dr by dx whole square plus dr theta, d and in bracket r theta by dx whole square root as function over x. At the end, it will come in x into delta xi. Summation I equal to 1 to n tends to infinity. It will finally come in integral calculus fx delta xi summation fx dx. Now it will be x from one location to another location, x going one location to another location, probably minus a to a whatsoever. Now we have dr by dx. How much radius is changing if there is change in x? If x is moving from here to here, then how much radius is changing? Radius is not changing. Radius length is exactly same everywhere. Radius is constant, so dr by dx will be 0. If I take dr theta by dx, dr theta by dx, then it will be r d theta by dx plus theta dr by dx. Again dr by dx is 0. Then it will be r d theta by dx. Okay, whole square root, same thing. It will become r d theta by dx. Let's calculate r d theta by dx. Okay, what is theta? Theta is tan inverse y by x. X equal to r cos theta, y equal to r sin theta. Then theta equal to tan inverse y by x. I believe it's straightforward. Then how much it will come? Tan inverse y by x. D of tan inverse y by x by dx. It will come as 1 by 1 plus 1. Tan inverse x differentiation is 1 by 1 plus x square. Then it will be 1 by 1 plus y square by x square into minus y by x square. X square minus y by x square plus y square. This is what it will come. Now we have r into minus y by x square plus y square. X square plus y square equal to r square. It will come as minus y by r. Makes sense? Minus y by r. Minus y by a if a is constant. What is y? Y is the square root of a square minus x square. Earlier we had a by a square root of a square minus x square dx. Now we have a square root of a square minus x square by a dx. Are they both same? Someone can try. Okay, if they are exactly same, what is the square root of a square minus x square integration? I believe it will be x into a square root of a square minus x square by 2 plus a square by 2 sine inverse x by a. This is what it is. If I try to do integration from minus a to a, first term will be 0, Second will be a square by 2 sine inverse x by a. A square by 2 into 1 by a, it will become a only. It will become a only. Now a by 2 sine inverse x by a. A is minus a to a. Sine inverse minus 1 minus sine inverse minus 1. Pi by 2 1. It will become pi a by 2. Okay, at least it is all right. Pi a by 2. If I had taken point as any point in the polar coordinate system is r comma theta, would not have come to r into a. Okay, r into a. It would have a would be missing here. It would be just pi. So our consideration of taking any point as any point of polar coordinate system inside Cartesian coordinate system, as far as if I have a Cartesian coordinate system, any point if I say this is polar inside Cartesian coordinate, then it will be r comma r theta, not r comma theta, r comma r theta. Because if I take r comma r theta with that fundamental, the way we are calculating the circumference, it is coming as pi a by 2. Now it's a matter of limit only. But if I had taken r comma theta, then it would have come as d theta by dx. D theta by dx would have come as y by a. Y is the square root of d theta by dx will come as y by square root of a square minus y by a square. It will come y by x square plus y square, y by a square. If I keep 1 by a square outside, y is the square root of a square minus x square. Its integration, if I take, then at the end, it will come as a square by 2. A square and a square gone. It will come only in pi. That is false. Pi cannot be the circumference of circle. Pi into a is the circumference of circle. 2 pi a. So it's just matter of limit I have to set. So our hypothesis as taking any point as a polar coordinate system inside, this is new thing. This is not anywhere else. That you can take any point as a polar coordinate system inside Cartesian coordinate system as r comma r theta, not r comma theta. Generally people think in that fashion. R comma r theta, it is people can calculate it. We will go through length vector also, and then we will go through variable. One way we proved it that our point is correct, r comma r theta. Anyway, this is how we divide into n part and then solve it, and we validated one assumption that our point in any Cartesian polar coordinate system inside Cartesian system, the point is r comma r theta because it is coming homogeneous now. Anyway, people can, now we will go with the variable radius also. R equal to cos theta, where radius is variable with the theta. Then dr by dx will not be 0. Means if we change in x, if we change in x, then radius will change. The variable radius is this. This is x-axis and this is y-axis. This is typically a curve for r equal to sine theta. This is curve for r equal to cos theta. We have seen it. R equal to cos theta. Radius is varying with the theta. R equal to sine theta. Radius is varying with the theta. We will try to validate with that also. One is dp by dx into dx, where p is xi plus yj, and one is dp by dx into ds, where p is r comma r theta. In both fashion, but here dr by dx will not be 0. If you move along x-axis, then radius is varying. Radius is not constant. See how radius is varying. This is r equal to sine theta. This is r equal to sine theta. If this is origin, radius means a line that connects the origin and circumference of the circle. So at the beginning, radius is 0. Slowly this radius is growing. When angle is 45 degrees, then radius is this big. When angle is 90 degrees, then radius is this big. When 145 degrees, when angle is 180 degrees, radius is 0. With variation of x changes the radius. Okay, then we will see if it is really. This is very tedious. We will take other example also. I have one funny example. Funny example means bank. If I deposit money in a bank, if I deposit money in the bank, say I deposit 10,000 rupees or $10,000. I believe $10,000 will be very big. Bank has announced that they give 0.05% yearly yearly interest, but that is continuous. There are two things. One is called yearly interest. Yearly interest means if someone has 10,000, after one, if someone has 100 rupees, he had deposited 100 rupees in the bank, and bank is giving recurring interest, that is 0.05. Then after 1 year, recurring interest per year. Then after 1 year, his money will become 105. Then in next year, 105, 5% of the 105. Then that will become whatsoever. It will become, I believe, 112 or something like that. Then for next year, interest 5% interest, 0.05 or 5%, it will be calculated on the next accumulated money. This is called recurring deposit. So cumulative deposit. So in cumulative deposit, one concept is that interest is calculated at the end of the year. One is interest is calculated smoothly. Smoothly. You can break at any moment, then it will give you. If I calculate interest smoothly as 5%, smoothly, then at the end of year, how much it will be? And if I calculate year by year, how much it will be? Now there is another fundamental. I deposit 100 rupees in the account, 100 rupees, consider 100 rupees in the account, and with the recurring interest of 5%, that is continuous calculation. Okay, then after one year, I added 10 rupees extra. Then after 1 year, I added 10 rupees again to whatever is going on. I keep adding 10 rupees. Tell me, after 50 years, after 20 years, after 15 years, how much it will be? Okay, can it be solved through dividing into n different parts and sum it and integral? Someone can think about it. If I have 100 rupees in bank is claiming that if you deposit a money, I'll give you 5% recurring interest. Means if you deposit 100 rupees at the end of 1 year, more or less it will become 105 rupees. Then if you go beyond one more year, then 5% will be calculated on top of 105 rupees, not on the beginning 100 rupees. Then it will go like this. Then person is very smart. Then after 1 year, he remembered that he had deposited 100 rupees, and it is very good. Then he is going to the bank at the end of 1 year, and he is saying, actually, whatever scheme I have, I want to add 10 rupees in that. Okay, you can add. Then he added 10. Next year again he went. Then he added 10 rupees there. Next year he again went. Then he added 10 rupees there. After that he went after 2 months. 2 months. Then he added 10 rupees there. I mean, this is a 10 rupees he is keep on adding. Then tell me, at the end of any t years, t is the time, any t year or any n years, at the end of n year, how much he will get? At the beginning, it is easy to come, but meanwhile, he is keep on adding and adding the same amount, s amount, some same amount, 10 rupees he keep on adding. Then how can it be solved through integration and can it be solved through the dividing into n parts? Someone can think about it. We will talk more on this. These are things generally, whatever explanation we gave, it is not available in any of the. I can bet on this. This summation and integration and vector together, this is not available. And if you don't mind supporting us, +91 is the India country code. 9483160610 is the telephone number. +91 in the country code. 9483160610 is the telephone number.